Alright guys, here's the last video for cumulative review number 16. Let's start here with number 17, which is a log equation. So, when I look at this, I note that there's logs on this side and 2 logs on this side. If we could get this to look like log of something equals log of something, if the logs have the same base on both sides, the arguments, or what's inside, would be equal. So if we looked at the left side, is there a way that we can get this to be 1 log? Yes, there is, because if 2 logs are added, that means that it's the same as 1 log base 4 with the arguments multiplied. So this side becomes log base 4 of x times x minus 1, and that would equal log base 4 of 12. So this is really log base 4 of x squared minus x equals log base 4 of 12. Because the logs have the same base, this piece, this argument, is equal to this piece. So x squared minus x equals 12, and this looks like a lot of the other examples, something we can factor. X squared minus x minus 12 equals 0. 2 numbers that multiply to be negative 12 and add to be negative 1. 4 and 3, negative positive. So x would be 4 and x would be negative 3. However, if I took negative 3 and I plugged it back into the original problem, it would cause this piece and it would cause this piece to be not real, because you can't plug a negative back into a log, because if you think about that logs are exponents, you can never plug anything into an exponent that makes it negative. So that means that 4 is our only answer. Sorry about that. That means that 4 is our only answer and negative 3 is out. So again, it is always good to check. Number 18, also a log equation, but a little bit different at the same time. So number 18, we have 2 logs again on the same side, this time log base e, but on this side we don't have a log. So unlike 17, we can't just set this equal to this because we don't have logs on both sides, but we can start with a similar type of logic. But before I start, I notice that I have this 3 in front of my log, which I did not have on the last equation. When you have logs in an equation, remember that if you have numbers in front, you can move them up as exponents. So this would be really ln 3 to the 4th minus ln of 2x plus 3 equals 7. So that would really be ln of 81 minus ln of 2x plus 3 equals 7. Because I have 2 logs on the same side, let's see if we can get it into a single log so that we could eventually maybe change it into an exponential equation. So if I have 2 logs subtracted, that is the same as 1 log with the arguments being divided. And that still equals 7. Now, as I said, unlike number 17, we don't have logs on both sides. So when we don't know what else to do, think inverse. Right now we have a log equation, so the inverse of a log is an exponent. So we can change this to an exponential equation. But what's the base? Well, if I see ln, I assume that the base is base e. So this is really e to what power? Well, logs are exponents, so it's e to the 7th equals 81 over 2x plus 3. So that is really e to the 7th over 1 equals this. So what I can do is cross multiply. So I'd have 2x plus 3 times e to the 7th equals 81. And if my goal is to get x alone, I could divide both sides by e to the 7th. So I'd have 2x plus 3 equals 81 over e to the 7th. Now, we have a choice. We could leave our answer exact, or we could write it as a decimal. If I'd like to leave it exact, to get x alone, you would subtract 3 and then divide by 2. So you could write your answer as 81 over e to the 7th minus 3, all divided by 2. That is a legitimate answer. But if you actually plug this into your calculator, divide, subtract 3, and then divide by 2, your answer would be negative 1.47, which, if checked in the original equation, and by original I mean all the way back at the beginning, it does work. Each side equals 7. Last but not least, number 19, this is a rational equation. This is what we saw at the beginning of the school year and again this semester. So when we have a rational equation, we would like to get a common denominator. And so we need to think about what each piece needs. But before I do that, I am going to factor this denominator to make sure it makes sense. This factors to be x plus 2 times x plus 3, which I like because this already has an x plus 2 and that already has an x plus 3. So now we need to think about what each piece needs. This one already has the x plus 2, and so it needs the x plus 3 to have the same denominator. So we have to multiply by x plus 3, top and bottom. This piece already has both x plus 2 and x plus 3, so no worries there. But this piece needs the x plus 2. So you'd multiply top and bottom by x plus 2. And so now if you look, all pieces have a denominator of x plus 2 and x plus 3. So if we would like to get rid of everything at the same time, we could multiply the entire equation by x plus 2, x plus 3. But before I do that, I'm just going to write this more neatly. We have x times x plus 3 on the top. My denominator is x plus 2, x plus 3, plus 2 over x plus 2, x plus 3, equals 5 times x plus 2 over x plus 2, x plus 3. So as I was saying earlier, what you could do now is multiply the entire equation by this common denominator, x plus 2, x plus 3, and if you distribute x plus 2, x plus 3 to all three of these, this and your denominators would cross out, so in the end, you'd only be left with what is in the numerator. So you'd have x times x plus 3 plus 2 equals 5 times x plus 2. Because you legally crossed everything out by multiplying by the common denominator. And again, factoring comes into play. A lot of this semester factoring is extremely important. So we have x squared plus 3x plus 2 equals 5x plus 10. If we continue to solve that, we would get x squared, let's move this over, has to be equal to 0, minus 2x minus 8 equals 0. Factor this. That would be x minus 4, x plus 2. So my two possible answers are x equals 4 and x equals negative 2. But again, it is a really good idea to look at your original equation. For a rational, remember at the beginning of the problem, because we're dividing, there's a couple things that cannot exist. I know at the beginning of the problem that x cannot equal negative 2, because it would cause this denominator to be 0, and x cannot equal negative 3, because it would cause this denominator to be 0. So if I look at my two answers, I got negative 2 as an option, so see you later. It can't possibly be negative 2, so it would cause this denominator right here and right here to be 0. So my only answer is x equals 4. And if you want to make sure that 4 works, feel free again to take 4, plug it into the original equation, and if you do, it works, and these two fractions together will equal that one. Alright guys, that's the end of the videos for cumulative review number 16. Feel free to rewatch them as many times as you need. Alright, good luck.